All right, that is all the example problems from the book that I wanted to go through. There are a couple homework questions I want to go over. I've picked out some even ones I'm going to walk you through, just because I think you might need to see a couple more examples when we revolve around things that are not the x or the y-axis. Homework problem number 12, I did not assign 12 to you. I think I assigned like 11 and 13. If you look at the PDF version of the notes that I've posted, I've worked through number 12 all the way through. It has parts A, B, C, and D. So I encourage you to take a look at that. I didn't want to make a video of it. We are going to look at number 16 together. So we are supposed to take the region bound by y equals 1 half x cubed, y equals 4, and x equals 0, and we're going to rotate this about the line y equals 4. So this is a cubic function. Clearly it goes through 0, 0. If you plug in 1, you get 1 half. And if you plug in 2, you get 4. Okay, so that's what this is going to look like. The other side of it obviously goes down here. We don't need that part of it. The line y equals 4 is here. X equals 0 is here. So this is our region that we are taking. And we want to rotate this about the line y equals 4. So this is our rotation. So when we do that, we're going to wind up with this thing. Except it's, a three-dimensional shape. So hopefully you can see what that looks like. All right, so we need to think about slicing this into our discs. And we're going to slice this direction. You can see those discs kind of forming here. That was not a fantastic one. Okay, so this might be one of our discs like this. We're thinking about the width of those discs. It is in the x direction, so this is all going to be in dx. We also have a horizontal axis of rotation, so that again tells us it's going to be dx. So our volume is going to be pi r squared, and it is in terms of dx, so I'll write that down. All right, since we're in terms of x, we're clearly going from 0 to 2. Already established that. And we just need to think about, there's no hole in this, it's just a disk method, so we just need to think about the radius squared. Now, every time we've done this in the past, our radius has been defined by our function, okay? However, that is not the case here. So if we look at this disk that I've created, which is not fantastic, if I want to know this radius, yes, it is defined by this function, but this function gives us the y value here. It gives us this distance. We want this one. Okay, so in order to find this, what we need to do is take our function and subtract it from 4. So it's going to be 4 minus 1 half x cubed. Okay, that's our radius. And again, that's because this function, that gives us this. We need this piece for our radius. Okay, so we have to do this line 4 minus that. And that's because we're rotating here and not down around this axis. Okay. All right, so now I think we are all set up here. We need to, foil that. That does not look fun. But we can do it. I'm just trying to find the blue chalk. All right, 0 to 2, so we have 16. Let's see, that's going to be minus 2x cubed minus 2x cubed, so minus 4x cubed plus 1/4 x to the 6th. We'll take the antiderivative of that, so 16, minus x to the 4th plus 128 x to the 7th. All right. I think so. From 2 to 0. Okay. I'm going to go ahead and do this one all the way out because I have an answer. I'm not entirely sure how I get there. We'll see. So we're going to plug in 2. So that's going to give us 32 minus 16 plus 2 to the 7th. I have a calculator here. Just ask the calculator. 2 to the 7th. 128 over 28. Let's reduce that. So 32 sevenths. When I plug in 0, they're all going to be 0, so I'm not going to worry about that. And then I might just ask the calculator about this. Convert it to a fraction. And we get 144 pi over 7. Let me check my answer key. Is that what I was supposed to get? It is. Hey, look at that. We made it. Yeah. I'm also going to do question number 20 in the next video.